All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and this is the introduction to C++. And we're working on our dungeon crawl game. And what we're doing at the moment is we're working on embedding Python into our application. So the first thing that I want to do here is create a header file to house this. So we're going to go here into header files, right-click, add, new item, and all we want is a header file. And I'm not going to do the class, so let's do a header file. And we're going to call this python3.h. And we're going to get rid of this and do our usual. If not def underscore Python 3 underscore h define this, and we'll go over here and copy this if I didn't copy it already, and we'll paste this in here. And now we can go here and get rid of this, and we can just go include Python 3.h, and we run this, and it should still work. It does. So that's good. So that saves us from having to put this mess wherever we need Python. We can just load that header file. So I'll close that for now. We don't need it. All right. So what are we going to do next? Next, we are going to create a special object that we're going to call we're going to think of it as our instance of Python. It's going to be the thing that's going to initialize and finalize Python. So we'll add, in this case, we're going to add a class. Nope, we're going to add an item, new item. I'm going to add my MIT class, and I'm going to call it py instance. I'll add that. So here's our py instance class, and here's our py instance .cpp, which will move down to the source files. We'll need that in a moment. So really, for this, all we really need are the single constructor and a destructor. So we'll go over here. I'm going to reverse these. We'll add our py instance tilde py instance. So what are we going to do in here? Well, we're going to I'm going to include it over here because we're going to need it shortly. I'm going to go pound include Python 3 Python 3.h. We'll go back over here to our py instance, and we're going to put here py underscore initialize, and here we're going to put py underscore finalize. Now, the purpose of this very simple class, we will demonstrate. If we go over here to our dungeon crawl, where I said py initialize, and I should have, to be proper, I should have said py finalize down here like I did up there, but I didn't do that. I forgot. So what we're going to do is we're going to go py instance up. We got to load, include the header file. So let's go include py instance. We're going to go py instance. There it is. Instance. What's going to happen is PyInstance is going to get called. We can do the same thing up here. We can replace this initialize with PyInstance. We'll test both of these methods. We can get rid of the finalize. When that class goes out of scope, it's going to finalize when the function returns. It's going to finalize it. So let's do this. Let's call this main2. And let's create int main void return 0. And let's call main1 and then main2 and see how that works. So we got hello world from Python and value equals 50. So what happened there? So with our PyInstance, this is just a local instance right here. Main1 is called. This instance is created. It does PyInitialize. When this goes out of scope, this goes out of scope, and it calls the destructor and does PyFinalize. So in the next one, it does the same thing. So we call main1, main2, and it will initialize and finalize. Now, there are some issues with that. We're going to have to take care of some things called reference counting when we start dealing with functions that return objects that we want to deal with, and possibly return from those functions to use elsewhere. So we may or may not want to finalize it. In reality, what we're going to do is hand off a reference to this. It's going to be fired up in main. We're going to pass around a reference to this so that functions can be called upon it, and we'll have the same instance of we'll have Python running all the time in our application, and it'll only go out of scope when main goes out of scope, and it'll finalize it automatically. That's how we'll use it. But we're just testing right now to make sure things are working. So there's our PyInstance. Now the next thing that we need is a thing that we're going to call a CPy object. And this is going to be a way, hold on. Okay. CPy object. So let's go here to the header files, add new item. I'll use my MIT class again. We're going to call this CPy. If I can type CPy object, and we'll add it. Now we're going to need, the thing about CPy object is, and we don't actually need the CPP file for this. CPy object. We'll remove that, delete it. We're going to have to create a number of constructors, and the reason for that is that we have to handle the reference counting of these objects that we created here. So we're going to go private. And we're going to include Python 3.h because we need PyObject pointer underscore. We'll just call it object. All right. Colon underscore object. And we're going to set this to null pointer. Okay, so if we just create a CPy object, it's got a null object inside of it. Now, we also need a copy constructor. So this is going to take a CPy object pointer as an object. CPy object pointer as an object. No. It's going to take a CPy object constant reference. And we'll call it other. And we're going to go object. Actually, I'm going to do it this way. I'm going to say this pointer underscore object equals other dot underscore object. And then we're going to call a method called addref, which we haven't created yet, but I'm going to put it here because we're going to create it right now because we need it. So let me find, just make sure I do this right. So addref is going to return a pi object pointer addref. And what is this going to do? Well, first of all, we want to find out if this object is valid. And if it is, what we're going to do is call pi x inc ref on underscore object. And then we're going to return underscore object. So what does that do? This is a Python function. Increment reference is what it means. And what it's going to do is increment the reference count on this object when we return it. So, but we can't access that in here because, as you can see, it modifies here. And this has to be a constant. So we can't call it on other. We have to call it on our self after we get the other object. So our copy of this will have that incremented reference. And we're going to create another function here, void release. And what void release is going to do is very similar to this, except we're not going to return anything. And it's going to be x dec reference object. And finally, it's going to set, in that case, object equals null pointer. So what does that do? Well, this decrements the reference count within Python. So these objects here are Python objects, and Python tracks them by reference counts. These functions are actually macros, I believe. They're implemented as macros. That's why they're purple. These macros take care of that incrementing and decrementing, but we have to call them whenever we do that. So we've got our release and our addref. Now next, we need what's called a move constructor. Let me make sure here. Yeah, the move constructor. Right. So we're going to go CPy object, CPy object, and it's ampersand ampersand other. And the reason it's ampersand ampersand is this is a special kind of reference specific to moving, and I will explain that probably in another video. This is a little bit more advanced, and we're trying to go slow in this. But to do this, we need to use some of these more advanced techniques. So we'll talk about that later. I don't want to slow this video down with too much detail about these things. But know this, what this is going to do is move that reference. Then the way it's going to do it is by calling standard. And this is a function within the standard library called swap. And it's going to be object and it's going to be other dot underscore object. And that's all it's going to do is move it from that one to this one. And I think I'm missing a include to call swap. I'm going to try to compile this. Seems to compile. All right, let me look that up real quick and see why it's not doing it in my other project, which is very odd. It may be because something else was included. There it is. It's in utility, and I'll have to examine my other project. I must have that somehow already defined in there somewhere. So anyway, now swap is working good. Okay, we've got our move constructor, and now we need an assignment operator. So cpy object ampersand operator. So this is going to return a reference equals cpy object. Darn it. cpy object ampersand other. Oh, and there's another thing. So this cannot throw add ref. Oh, that's because I don't have this completed yet. This has to be told it cannot throw exceptions, and this cannot throw exceptions. Okay, so we're going to do the same thing that we did before up here with the standard swap, but we're also going to return pointer this. We're going to return a reference to this object, and then we need a destructor. Tilde cpy object, and all we're going to do in this constructor is call release. Now that we've got our constructors and our release and our add ref all fixed up, we need a couple other things, a few other operators and functions. So py object pointer. Now this is the Python object. Get object and simply return underscore object. So this is our getter for our object, and then we want to have a py object pointer set object py object pointer obj, and all we're going to do here is go underscore object equals obj, and then return underscore object. So far so good. Now I don't know if I've talked about overloaded operators. I think I did some with the stream operators perhaps, but that's what we're doing here pi object pointer operator, and we're going to overload this dereference operator for pointers on this object, and we're just going to have it return underscore object. So when you use this to dereference this object, what you're actually getting back is the internal object and not this object, which is it's going to look kind of strange, but we'll work through it. And now we're going to do a bool, and we're going to call this function is, and this is a simple boolean. We're going to return underscore object question mark true colon false. So if object is null, it'll return false. If it's not null, it'll return true. Now we need another operator, and this is a simple one, operator pi object pointer and we're just going to return object. And what that means is when we dereference this with a star in at the left of it, instead of getting a dereference of this, we're going to get this object pointer back. And we got to have a semicolon up here. All right. And then one more operator bool this, and it's going to return the same thing, object question mark true colon false. And I will explain some of these functions as we use them in the future as we move along handling these objects, but most of these are so that we can treat these objects pretty much as though they were this pi object, but it handles our reference counts for us and allows us to get it out, pass it into functions, dereference it, and so forth, and handle it just as though it were that raw pointer. In some respects, this is almost like a special kind of shared pointer in a way, but it's one geared, instead of the shared pointer has very special handling characteristics. This one is geared specifically to deal with Python and just kind of hang on to the object for us. So now we can test this by going back here to Dungeon Crawl, and let me find an example of its use. So instead of pi object, we can go cpi object and not a pointer p. We got to include it. And then p equals, why doesn't it like this construct? Let's try running it in case that's just IntelliSense. No, it doesn't like it. I think I made a mistake over here. Let's go check it out. I think it's with this equals operator. Equals operator. Oh, I think I didn't do the other equals operator. Down here, right after I skipped it. Yep, I didn't do it. So what we have to do is go pi object pointer operator equals pi object pointer obj. So this is a second overload of the equals operator, whereas this equals operator is like a copy equals from cpi object references to cpi object references. This one is pi object pointer returns a pi object pointer and takes a pi object pointer and fills us in going underscore object equals obj, and then very importantly it returns it underscore object, returns that object. So now if we go back to Dungeon Crawl, our little error went away and we were calling main2. So yeah, here it is, main1, main2. Let's see if our object works. And value equals 50. So what happened there was, in this, instead of using that pi object, we're now using our cpi object, and we're assigning it directly from this, as though it were a pi object. But here you notice it's scoped to this. It's no longer a pointer. It's got a pointer in it, but when this function goes out of scope again, what happens over here is the destructor gets called, and that calls release, which release decrements the reference count so that Python knows that it's been disposed of, that we no longer need it. So it's kind of turning, we got to work with the system of Python and how it puts those things together. So let me check the time here and see where we're at. We're right at 26 minutes on this video, so I think I'll end it there. I'm going to recap real quick. We created a Pi instance. This Pi instance is a thing that will kick off Python for us, start it up, and shut it down properly. We're going to add some things into this Pi instance that allow us to call on Python to do a whole variety of things, and we'll, of course, use this Pi object for moving information back and forth to Python. And so that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I will see you in the next video. Thanks for watching.